So as we look at problem 3 and 4, I'm going to run through these because hopefully you're getting into the notion of looking for the select shifts horizontally, vertically, uh, up or down. So if we take a look for problem 3, they have us graphing out the function f of x when it's equal to that x cubed, whatnot, but we'll start first with the parent function because we may need to get familiar with this again. So x cubed, we have that graphed out. It's curvy, it's wavy. This is the first course that you have probably seen this equation in, unless you've sporadically Googled it just out of curiosity. The domain and the range on this is going to be all real numbers. We could use any x value, believe it or not, and we could cube it and end up with some number. The weirdness here is that it grows pretty quickly after you plug in any type of number. So that's why it's continuing up and to the right, up, down, and to the left. We can plug in anything and get any type of outcome. So if we were then graphing out the new function, where this is equal to, and we won't graph this just yet, but negative parentheses x plus 1 being cubed, and then deducting 3. We'll see what that looks like in a second, but I'll give you a moment to just think out, how is this changing? What's going to change with these new terms thrown into the mix? So recall HIVO, that's one thing. So if we look at this from left to right, hopefully you notice that this is subtracting this binomial, x plus 1 being cubed. So whenever that happens, that's definitely going to be flipping over the x-axis. And the reason that is because of this subtraction sign here. Because a is -1, which is less than 0, and that's the main idea, is that if it's a negative number, it's flipping over the x-axis. From HIVO, you should be able to think, well, the horizontal shift that occurs inside, I'll even show it, inside, that's crucial. The horizontal shifts are all occurring from inside the binomial, where in this case, we see x plus 1. This is where we need to think opposites also. So we know that there's a horizontal shift. Since this is adding 1, we kind of want to think opposites. So this is a horizontal shift, positives going to the right. So we actually want to go to the left 1 unit. And then finally, with the VO portion, vertical shifts occur on the outside of the equation, or outside of where the meat and bones is of the function, where this is subtracting 3. So there's definitely a vertical shift. Since this is -3, this is going down 3 units. And that's all we can really say about this one. If you're not convinced that this is going to be that final type of outcome, we can take this one step at a time. So if we had to subtract just x cubed, hopefully we can see that this is shift over the x-axis. This could also be considered shift over the y-axis, but that's the main reason why it's shifted over the x-axis. Well, actually, there's no reason. This is just one of those weird types of graphs. We then saw that there was a horizontal shift 1 unit to the left. Hopefully you can see that change from the original parent functions. So that's cool. I think this is helpful if you're not convinced that a lot of these points are shifting. And we also saw that this was deducting 3 at the end. So if we were to compare this with the original one, it's definitely shifting down 3 units, but we've highlighted on everything we need to highlight on: the vertical shift, the horizontal shift, the vertical shift. So in comparison to the parent function, it's definitely different in a lot of aspects, but it's really only 3. So that's something to keep in mind with this. You're looking for 3 types of changes for the most part. Does this move horizontally some type of way, vertically some type of way? Does it scrunch up? Stuff like that. So if we clear this all out, looking at the final setup, we have f of x equals x squared. Domain is going to be all real. The range you should know is being from 0 to infinity. As far as the new function that they're asking us to graph, let's call this g of x. And this is equal to 2 parentheses x minus 3 being squared. This is also adding 1. We'll talk about the graph in a second, even though you saw a sneak glimpse, but I'll give you a moment to think about what's important with this graph or function. What's going to change? Well, I know that the a term is 2, so the coefficient outside the parentheses is 2. This implies that it's going to be moving at a quicker pace, so this is going to be shifting and stretching out, going a bit further up in a faster motion, so stretch. I also see that inside the parentheses, the horizontal shift is -3, but in reality, the horizontal shift is adding 3 units, so 3 units to the right. And the vertical shift round the outside, this is adding 1 at the end, so this implies that there's a vertical shift of up 1 unit. So we see that the point at the origin, 0, 0, this was modified, moving 3 units to the right, 1 unit up, which is stating the horizontal and vertical shift. We see that they intersect, which is interesting. That doesn't always happen. But we also can see that this is moving in a faster motion. It's more slimmed down. It's moving in a quicker rate. Think if you were at work and someone said you're working twice your normal rate, you'd be working at a faster rate. You're moving quicker. You're getting things done in a fast fashion. If we're going for domain and range on this one, domain is still all real. This always happens for quadratics unless it's a rational one, but the range slightly different now. Looking at our very bottom point, 3, 1, hopefully we can say that the range is going to be from 3 to positive infinity. So that's this section. There's a lot going on. Take your time with it. If you get stuck, use a calculator. But the sooner you get familiar with the horizontal and vertical shifts, the easier this section is going to be. A lot of this is based off of original equations, parent functions. If you need a refresher on that, I'll make sure that there's a link to get you back in tune with everything. But please try to take note of the vertical and horizontal shifts sooner than later. It'll make your life easier, I promise.